my god. Okay. That seems to be working. So we're going to start in just a minute. I'll do a little introduction as I usually do because it's better for the final video on the YouTube channel. You can catch this on the YouTube. The live is also live over there. But to be honest, I don't really look at the comments. It's too hard to keep my eye on so many screens. So let me just get right down to it because it's already 10:30 and I've got shit to do today, people, and I'm sure you are busy too. So, hi, my name is Dr. Eloise de Vance and welcome to Astro Live. This week we have a very special episode because I couldn't find an article I really wanted to talk about last week. There was nothing that came out in the literature that was particularly riveting, especially for the layperson. So I thought that we would do something a little bit different today. By the way, if you can't hear me, if my lips are moving, but you can't hear what I'm saying, you should let me know because I am looking at the Twitter chat. It's right here. And I want to make sure that there's as few technical mishaps as possible because I know that I've got many of those. It's very difficult to actually stream. There's so much going on and so much to keep track of. So let me know if everything is working well or if there's any problems that you seem to be having. So we're going to be doing a quiz. And why a quiz? That's because I was pissing around with my husband a couple of days ago and he decided to make me take a quiz that he wrote for his students. And I had a blast. It was very, very fun. And I figured that it was something very simple that I could create for y'all and we could play together. What's the prize? Well, very interesting. The prize is eternal glory. And only you will know if you've won because you don't get to put your points in the comments because we're not competing, you know, we're all friends with each other. You win automatically. It's brilliant. Okay, so what's that going to be? The Astro quiz is very simple. There are only two rules. First rule is Googling is cheating. Do not Google the answers as you go. I'm going to give you the answers at the end. It's going to be fun. It's going to be easy. I'm going to give you so many anecdotes. Well, I'll try. And second rule is don't put the answers in the comments. Don't be a dick. Please be nice to people. Now, I'm going to try and fill in some gaps at the moment. I'm going to try and stall because I am looking at the Twitter live and it is frozen, completely frozen. And I don't know if you can actually see my screen. I've got another screen going and for some reason I can't see it. And it is very irritating. Why is my phone so freaking shit? I know I'm not supposed to swear, but this is not kid-friendly content. I'm not sure that kids would enjoy this sort of stuff. Why can I not see myself? Jesus! Oh, maybe it's just my phone. I'm sorry, I'm gonna just get Twitter on another tab on my computer, see if I can actually get the live to work. I don't want to be talking for 15 minutes without anybody being able to listen to me or watch me because it's happened before. If you've never been on Astro Live, then, oh my God. Okay, so you can't actually see the screen. I'm seeing that now. So let me try to share now. There's a 3-minute delay. This is so annoying. Okay, let me just crack a few jokes whilst we're waiting for this stuff to be resolved. I'll probably cut that stuff out for the YouTube replay. I'm definitely gonna cut out all of the shit that we're doing right now. I think you can see my screen though. So we are on. Okay, Astro quiz, very simple. Googling is cheating. Don't put the answers in the comments. We will have one round at the end of whatchamacallit, wrong answers only. So I'll ask you a question, very simple one, and I only want wrong answers, and you can absolutely put that in the comments for everyone to see it, and I will read out the ones that I find the most funny. Okay, let's go. First question. If you want to work. Okay, this is the sun. The sun, our beautiful, the heart of our solar system. It's massive. It's mostly made of hydrogen, and helium, because those are the main components of the universe made after the Big Bang. What I want to know, though, is how big is it with respect to the rest of the solar system? What fraction of the mass of our solar system is locked up in the sun? Now, don't panic. I'm going to give you a few options. Is 50% of the total mass of the solar system locked up in the sun? Is it 78%? Is it 91%? Or is it 99%? Now I'm going to give you a few seconds to think about it. I will not give you the answers yet. You're going to have to wait until we go through all of the questions. There's only 10 questions. This is not going to last long. Again, this is just for fun. And you'll get 1 point if you get that one right. Okay. Let's move on. Okay. Let's move out a little bit. We've looked at the solar system. Let's think about stars in our neighborhood. And in particular, what is the closest star to our sun? How close is it? Is it 0.4 light years away? A light year, by the way, is the time it takes for light to travel. It's the distance that light will travel in 1 year, really. So the closest star to our sun is Alpha Centauri. How far is Alpha Centauri? Is it 0.4 light years away? Is it 4 light years away? Is it 40 light years away? Or is it 400 light years away? Okay, think about that. It's a toughie. It's a tough one. You know, factors of 10 really make a difference in our everyday life. But on the scale of the universe, it's kind of hard to picture these numbers. Okay, next one. That's one that I see often on the internet. People being all smug about this, like they'll tell you, you don't need to bother wishing upon a star because the stars you see in the night sky are long dead anyway. Now, is that true or false? Is that statement correct, that the stars you see in the night sky are dead already? Okay, think about it. Think about how far they might be and how long a star lives. We'll talk about that at the end. Okay, next question. How many stars are there in the Milky Way? Again, a very tough one because these numbers are so mind-boggling. It's hard to make sense of them. Okay, is it 200 million stars in the Milky Way? Is it roughly 2 billion stars? Is it 200 billion stars? Or is it 20 trillion? Now, to help you with the numbers, million is, there's 6 zeros, so 200 and then 6 zeros. 2 billion is 2 and 9 zeros, and 20 trillion, that's a 20 with 12 zeros. So that's a lot of zeros right there. By the way, obviously, it's a bit hard to know how many stars there are in the Milky Way, so that's why there's an approximate in front of it. For the actual number, whether it's 2, 3, 4, it varies depending on the estimate. Okay, next one. How wide is the Andromeda galaxy on the night sky? Andromeda is one of the nearest galaxies to Earth. Will actually collide in about 4 billion years. It's going to be interesting. Now, because it's so close relatively, and it's such a big galaxy, I just want you to imagine how big it looks on the night sky compared to objects that are closer. Okay, so is it about the size of Jupiter? Is about 6 times the size of Jupiter on the night sky. So Jupiter is obviously much smaller than Andromeda, but it's much closer. It's that kind of relative size. Is it about the size of the moon, or is it 6 times the size of the moon? And I mean in this particular direction, okay, in the long direction, not in the short direction. So can you fit 6 times Jupiter here, or 6 times the moon, or 1 time the moon? Think about it. Okay, next one. We're getting close to the end, and then we're going to start with some of the answers and anecdotes I wanted to talk about. Most of the iron in the universe comes from either the Big Bang, thermonuclear supernovae. So thermonuclear supernovae, I'll help you a little bit. Those are supernovae from low mass stars, so white dwarfs. Is it core collapse supernovae, the supernovae that happened at the end of high mass star, of the life of high mass stars, or is it kilonovae or neutron star mergers? Okay, where does most of the iron come from in the universe? 1, 2, 3, or 4? Okay, now we're heading towards telescopes. I've asked you a few questions about stars. I figured that it would be interesting to look at technology as well. So, because astronomy is not just interesting facts about space in the universe, it's the things that we observe the universe with. So this is the Hubble Space Telescope. When was it launched? When was the Hubble Space Telescope launched? Was it 1987? Was it 1990? Was it 1993 or 1997? Okay, next one. this telescope is called the Very Large Telescope, the VLT. And what I want you to think about is how big is the primary mirror of the VLT? Now, just to help you around with the jargon here, so primary mirror is the biggest mirror in a telescope. There's usually a whole bunch of mirrors, at least 2 in most modern telescopes, and the primary one is the largest one. So is it 5 meters, 6 meters, 7 meters, or 8 meters? Right, okay, we've got the last question before the wrong answers only round. And this tube of nothingness in the middle of of nowhere, that is a part of the LIGO observatory. How long is each arm of the LIGO observatory? So LIGO, this is kind of a question for the nerds. There's a lot of assumed knowledge here, so let me help if you're not sure what we're talking about here. LIGO is the gravitational wave detector located in America, and it's made of 2 arms that are at right angles like this. I want to know how big each of these arms are. Is it 400 meters? Is it 4 kilometers? Is it 40 kilometers? Or is it 400 kilometers? And yes, I apologize, it's not in miles. You can do the maths yourself in the meantime. Right, final question, wrong answers only. Who was the first person, not man, notice, to walk on the moon? Who was the first person to walk on the moon? Please make me laugh, because I'm having a tough day. Okay, let's move on to the answers, which, I didn't make slides for the answers. I'm a fucking idiot. Okay, we're just going to have to go back to the top, and I will just give you the answers. It will be just fine. What's going on here? Woo! We're scrolling back up. And you get 1 point for each question that you get right, basically. And if you get more than 5 points, then you've done very well, really. Okay, so what's the fraction of our solar system that's locked up in the sun? By mass, obviously. Now, that's a tough question because we think of the size of objects, but we don't often think of their density. And the sun is incredibly packed. It's incredibly dense in the heart of the sun. So actually, more than 99% of the mass of the solar system is contained in the sun. It's actually closer to 99.9%. So even that is a low balling. But I just didn't want to have too many decimal places in this question. It would have looked ridiculous. But yes, it's a crazy amount. It's incredible the number of stuff that you can do with a tiny fraction of the mass of the solar system, the number of planets, the number of asteroids that you can create with all of that stuff. Okay, the next question was, how close is the nearest star from the sun? So that's Alpha Centauri, that's our nearest star. And the answer is 4 light years. So that was 4 light years away. It would take about if we could travel at the speed of light, it would take about 4 years to get to Alpha Centauri. It's never going to be that quick. I can promise you that it's never going to be this quick because we can't travel at the speed of light. It's just physically impossible. That's not just the realm of science fiction. It's even beyond that. So if we were to try and travel to the nearest star, we would have to have a party that's much larger than the exploration parties that we've had before for the moon or that we're even organizing for Mars, because it would be a journey that would take maybe generations, right? So it would be a completely different endeavor. True or false? Are the stars that you can see in the night sky already dead? No, they're not. They're absolutely not already dead, because the stars that you can see with your eyes, I should have maybe said with your eyes. Obviously, with telescopes, you can see so far into the universe that obviously these things are already dead. Absolutely. But the stars that you see with your eyes in the night sky, they're very close and very bright. Okay, they have to be very close because otherwise we wouldn't be able to see them. And I think the furthest star that you can see with the naked eye is about 4,000 light years away. So you're looking at it the way that it was 4,000 years ago, and stars live for millions of years. So it's not gonna, that's just false, completely false. Okay, next one is, how many stars are there in the Milky Way? Well, that's about 200 billion. The actual ballpark estimate that people give is between 100 and 400 billion stars. Now, the other numbers that I gave you are not ridiculous for the size of galaxies, actually, because there are dwarf galaxies with as few as like a few thousand stars, a few million stars even. And I think that the largest galaxy has like 100 trillion or 1,000 trillion solar masses, something like that. So all of these masses, numbers of stars are valid for galaxies. They're not, I mean, they're crazy numbers, but they're not that crazy for galaxies. But 200 billion is what we were looking for the Milky Way in particular. Now, how wide is the Andromeda galaxy on the night sky? Okay, if you could see it with your eyes, by the way, because you can't see it with your eyes, it's too faint. And if you could see it with your eyes, it would be extremely shocking because it is 6 times the size of the moon. The moon looks something like this big compared to Andromeda. It's ridiculously large. And so if you could actually see it with your eyes, it would be breathtaking. But you absolutely need a telescope to be able to observe it because it's just too faint, it's too dark, and it's outshone by other things in the sky, including the atmosphere. Next one was most of the iron in the universe comes from thermonuclear supernovae. That's the answer we were looking for. It's more advanced. I get it. You know, if you followed me for a while, you'll probably know the answer to this because I talk about supernovae a lot. But this is a toughie. So the Big Bang made hydrogen, helium, and pretty much that's it. A little bit of lithium and not much else. All of the what we call metals in the universe. So anything like heavier than helium was created in stars. Most of it was released in supernovae, core collapse supernovae, and the phase just before they die, called the AGB. Now, a lot of like calcium, oxygen, like what we call intermediate mass elements are made in core collapse supernovae, but thermonuclear supernovae create most of the iron because they're made of they come from white dwarfs that are made of a lot of carbon and oxygen. And when it bursts, when it explodes, it completely burns that oxygen, that carbon, and all of that directly to iron. And that's where it comes from. And kilonovae make gold, platinum, silver, and all of that shiny stuff that we know and love. Okay, back to telescopes. That's Hubble. When was it launched? Well, if you've paid attention to astronomy Twitter over the past few months, you'll know that it was launched 30 years ago. So it was launched in 1990. It was in April 1990 that it was launched, and there's been actually a massive campaign to celebrate the 30 years of Hubble, and you can see some beautiful pictures. I highly recommend you check NASA's website because it's incredible. It's out of this world. That was a bad one. Okay. Moving on to the Very Large Telescope. How large is the Very Large Telescope? Well, it's 8 meters across. It's the largest, 8 meters, about the largest size that you can make a single mirror. And that's what it is in the Very Large Telescope. The primary mirror is a single mirror. We call it monolithic. If you make a telescope that's bigger than that, there are telescopes with bigger primary mirrors, but you'll need to make it in segments because otherwise it just doesn't work. It doesn't cool well, and it's just too technically challenging. And finally, the LIGO question, which is a little more technical once again, a little bit more niche. Each of these arms that have a laser going through them is 4 kilometers long, which is ridiculous in and of itself. 400 kilometers, I don't know even how that would work. You'd have to go through state lines, I imagine, because it's in the US, so I don't know how that would work. But that's pretty much it. And I don't see any comments to answer this question. I don't think this was a very fun experience for most people because I lost most of you, but it's fine. We try things. I see what sticks, and if it doesn't stick, then I move on to something else. So I think we're going to leave it here. I gave all of the answers that I wanted to give for the few people that did stick through with it, and And that's it. I think we're going to. It's already 10:50 here, so I really need to go to work. So there's a bit of lag, so I don't think I'll be able to catch any questions if you want to put them down here. But if there's anything you want to ask me, you can always add me on Twitter. You can always leave me a comment, and I'll be very happy to answer anything, whether it's to do with the stuff that I explained here or something completely different. Okay, I love you all, and I think I'm going to leave it here for today. Bye!